Okay, let me talk about Bayesian reasoning. I know we have heard this term before, but um, it is very important concept in statistics or any field because we live in the Bayesian world. What do I mean by that? Is Bayesian reasoning or Bayesian rule has it incorporates the idea of conditional probability. We live in a conditional world. Everything um, we when we make decisions, we try to factor in the environment around us, the other factors that come into play when we make decisions. So, Bayesian reasoning, what is it? It simply says you should update your belief in light of new evidence. If you have new evidence, you should update it. You can't just rely on the old evidence. And we pretty much do that in most of the field. Besides, like for example, religion and politics, we try to cling to our existing belief. Otherwise, we try to update ourselves with the changing world. And Carl Sagan said extraordinary claims require external evidence. So if you understand the concept of Bayesian reasoning, you'll understand what that means at the end of the this video. So the Bayesian formula is this. What is the probability of, on the left side, what is the probability of null hypothesis being true given the data we got from our experiment or anything like that, is simply computed by um, at the numerator, what is the probability of null hypothesis? What is the prior probability? What is the credence of that null hypothesis? Is it a highly reliable hypothesis, or it is on a shaky ground? For example, if you tested positive for COVID-19 during the COVID-19 pandemic, probably you got the COVID-19 disease because many people got the disease, so it had higher prior, right? Higher prior probability or credence. But if you tested positive for let's say prostate cancer, I don't know exactly the disease frequency, but I'm sure it has way less incidence than COVID-19. So the chance of getting disease, even though you got positive test, is low because your prior is low, small. Multiple, and this number is multiplied by this is the condition, right? What is the likelihood of getting this data if null hypothesis is true? This is likelihood of data divided by what is the total likelihood of getting the data. All these terms gives you what is the total likelihood of getting the data under null hypothesis. This term is same as numerator. It gives you what is the likelihood of getting data under null hypothesis, and what is the likelihood of getting data under alternate hypothesis. So simply you add and you get the total probability of data, right? So this term on the numerator is also closely related to p-value, which we calculate in our research studies, which assumes that p-value, the null hypothesis is true. It already assumes that null hypothesis is true, and what is the likelihood of getting data if null hypothesis is true. And if we translate this formula into our realistic, real world situation, it comes down to like this. This is in This is more relevant in criminal justice, right? So your null hypothesis is the suspect is, your null hypothesis is suspect is innocent. That's how it starts, right? You are innocent until proven guilty, which is suspect is innocent. And what is D here? I is innocence. Here D, data. We are talking about DNA match. Did the suspect's DNA match DNA match with DNA from crime scene? DNA from crime scene, right? And it is simply asking, hey, what is the probability of that suspect being innocent given his DNA matched the DNA at the crime scene? We are asking this. And to answer that question, we have to use the Bayesian rule, which says, what is the probability of innocence even before the DNA match data was available, right? What is the probability of DNA match given the suspect innocence? Divided by, remember this numerator is also appears here. What is the probability of innocence here? Probability of match given innocence plus probability of guilty and probability of probability of match, DNA match given guilty. Let me explain this denominator. This denominator is simply saying, what is the DNA match? What is the probability of DNA match? Remember, DNA could match the two possible scenarios. Sometimes your DNA simply matches with other people. I know DNA is a unique thing, and you would assume that DNA doesn't match with anybody else's DNA. However, when they test DNA, when they test the DNA, when they do the fingerprinting, they won't test your whole genome. They only test certain markers, unique markers, and still there is a chance that the DNA, your DNA match with somebody else's based on the certain markers being tested. So there are two cases. One is true positive, you are guilty and your DNA matches, and there are some people who are innocent but their DNA just simply matches. It's a problem. It is a probabilistic thing, right? So what is the total probability of DNA matching? That's what it is asking for, DNA match. Remember the denominator here. What is the total probability of data? What is the total probability of DNA match? That's what it is asking. And let me explain this term here. What is the prosecutor fallacy, right? Prosecutors, they tend to trick you by saying, hey, look at that. The suspect's DNA matched with the DNA from the crime scene. They're using this here. The probability of matching somebody's DNA with the suspect's DNA is 1 in 100,000. it is so rare that this person should be, the suspect should be the, his DNA matched, so he should be the criminal. He should be the one who killed that guy, right? One in, so rare, 1 in 100,000, so rare, so he must be the criminal. But you can't use this to come and to convict somebody with this. This is asking, even though your DNA matched, even though his DNA matched, still there are chances that somebody who is innocent could simply match the DNA with the suspect, with the DNA from the crime scene. So the judge is looking for this. What is the probably innocent given the DNA already matched? But prosecutor is saying his DNA matched, and look at that. This is so rare. It's not possible unless you are a criminal. So they are just trying to confuse you. Let me explain this with the example here. A crime is committed in a city of 100,000 people, 1 million people. Investigators know the criminal is one person in the city. They say one person committed crime, DNA test is performed on a suspect, and DNA matches the crime scene sample. Now we need to assume suspect is guilty. We need to assume that if the suspect is guilty, the probability DNA match is 1, right? If you are guilty, your DNA should match. Probability DNA matching with is given guilty is 1. Okay. What is the probability of match, DNA match, given you are innocent? Is given by let's say probability of match given innocence is 1 in 100,000. Let's say probability of DNA match given innocence is 1 in 100,000. What is the total population city? 1 million. Now, we need to calculate these terms, right? We need to calculate what is the probability of guilt. What is the probability of guilty in the population? Is 1 over million. There's only one person who is guilty in 1 million population of that city. That's probably guilt. What is the probability of innocence? What is the probability of innocence? We need to calculate the prior probability of innocence, right? That means if one person is guilty out of 1 million, there are 999,999 999,099 people are still innocent. $999,099 people are still innocent. All right, that's the probability of innocence. Now, what is the probability? Now we know this. Look at the formula. We calculate probability of guilty. Okay, we calculate the probability of guilty. Which is this one. We calculate the probability of innocence. Probability of innocence Um, Probability of match given innocence is 1 in 100,000. Probability of match given guilty is 1. We need to plug this value in the formula here, which says probability of innocence given DNA match equals probability of innocence times probability of match given innocence, the denominator total probability of DNA match, which is simply calculated by adding probability of match given innocence and probability of match given guilty. Match given guilty. So let's plug in these numbers here, which is 999,999 times for match given innocence is 1 in this is divided by 1 million. Times this plus what is the probability of guilt? 1, right? Probability of guilty is 1 over 1 million. Right? Times what is the probability of match given guilt is 1. So if you solve this, it will come down to 999 over which is around 0.90 or 90%. Look, prosecutor is saying the chances of you being innocent is very unlikely. You're saying 1 in 100,000. That would be like 0.00001 something. But after we do calculation, we are seeing that the probability of, even though his DNA matched with the DNA from crime scene, it is possible that he's 90%. It is highly probable that, or 90% probable that he is innocent. This is percentage given, even though he's innocent, given his DNA matched, is still the probability of innocence is 90%. Highly probable for being innocent. So